What unfolded at CERN wasn't just another experiment, it was a boundary-breaking event that, for the briefest flicker of time, overturned the rules of existence itself. For 0.003 seconds, the framework of reality twisted. Gravity bent unnaturally, information bled through the cracks, and the universe may never fully erase the imprint of what occurred. In 2023, deep inside the Large Hadron Collider, physicists pushed science further than anyone believed possible. The upgraded machine surpassed energy levels once dismissed as unachievable. For the first time in history, researchers didn't just generate a singularity on the quantum scale, they forced it apart. What followed defied belief. Inside the chamber, detectors screamed with radiation levels beyond all precedent before the security systems shut the test down. Then, sudden silence. The recorded data revealed something no model had ever predicted. The singularity had fractured into two discrete entities, both blazing with Hawking radiation so intense it overwhelmed the most advanced instruments on Earth. But even this wasn't the most shocking outcome. The split left marks on reality itself, a fleeting tear in spacetime. Had CERN inadvertently cracked open a passage through the very fabric of existence? And if so, what might have glimpsed back through before it closed? Stay with this, because what emerged is stranger than imagination itself. This was never part of the original program. The session wasn't public, not even broadly known across CERN. In a late night, high-energy configuration of the collider, something appeared, a microscopic singularity, searing hot, unraveling rapidly. Then came the impossible moment. It divided. Not decay, not collision, but a breach of nature's foundational law. They witnessed the unbreakable snap in half. The data wasn't just unusual, it fell outside everything we understand. The collider had been stretched beyond its intended threshold. Only a skeleton crew watched as detector readouts spiked to shocking extremes. At first, we assumed a malfunction, stated Dr. Thomas Henriksen, one of the project's senior physicists. The energy trail didn't align with anything our theories predict. What emerged was a black hole tinier than a proton, expected to vanish instantly via Hawking evaporation. But instead of disappearing, it split apart. Instruments tracked not one, but two signatures radiating at double the projected intensity. Chaos consumed the control room while emergency systems fought to manage the surge. In the fractions of a second that followed, the chamber experienced energies rivaling those of the birth of the universe. Components warped, metals melted, barriers buckled. Yet the baffling part was not the damage, it was the record itself. Physics shouldn't have allowed this to happen. Our current frameworks insist a singularity cannot divide. So when the impossible takes form before your eyes, what does it mean? To split one is to rip the fabric of space twice over. If a singularity is a sealed doorway, CERN pried it open from both ends. Beyond it, something else seemed to stir, and for the briefest span, they caught signals of it. Black holes are already paradoxical, points where the known laws collapse. Places of infinite density where space and time evaporate under controlled conditions. CERN created a miniature of such an object, but instead of fading, it bifurcated. Imagine sawing into the kernel of reality itself. That's what happened inside that chamber. The readings indicate that for a flicker in time, the neighborhood of space behaved differently. Gravity slipped from Einstein's equations. Vacuum energy fluctuated, as though nature's constants had been rewritten on the fly. Breaking through once was catastrophic enough, but ripping it twice at once opened what can only be described as a temporary window into somewhere else. Witnesses reported a radiation signal entirely alien to known physics. It resembled not chaos, but something patterned, something structured. It was as if information leaked through, not generated here, but arriving from beyond. This wasn't a discovery of particles. It was tampering with the underlying framework of reality. And humanity has no comprehension yet of what exactly we saw, or worse, what might have seen us. Afterward, detectors continued recording signals. The spikes did not register as noise, but as interference, as though two patterns were colliding and resonating back. Some scientists now suspect it was a feedback loop, energy from the split feeding back into the quantum field itself, amplifying and sustaining for a blink before collapsing. But before that collapse, One truth crystallized: the information sealed inside that singularity didn't stay bound. For a fleeting instant, it escaped. The readings gathered in those fleeting milliseconds have sent shock waves through the global physics community. What was recorded wasn't just raw, chaotic radiation, it was structured. We've never seen emission patterns like this, remarked Dr. Elena Costes of MIT's Quantum Division. The data points toward a transfer of information. Such a result defies one of the cornerstones of black hole theory. According to Stephen Hawking's ideas, any information swallowed by a black hole is lost forever, scrambled beyond perception. Yet what occurred in this chamber was the opposite. The fractured singularity seemed to release information in a deliberate, organized rhythm. Detectors picked up repeating pulses with astounding mathematical precision, more like a code than random noise. It was as if the vacuum itself began to oscillate. Explained theorist Dr. Richard Hammond. The energy from one fragment appeared to amplify the other, establishing what looked like a quantum feedback loop. This loop generated gravitational disturbances intense enough to warp the very properties of local spacetime. For those brief instants, the constants that anchor our universe, the forces, the fields wavered visibly. Inside the chamber, sensors documented unexplained electromagnetic spikes. Computers froze. Systems log anomalies one observer described simply as reality glitches. The most unsettling interpretation is that, just for a sliver of time, the experiment bridged into something beyond our universe, an alternate dimension, a parallel cosmos, or something even stranger. The data points to one sobering possibility: something crossed the boundary. Information bled outward from a place assumed impenetrable. And if that can happen, the reverse may also be true. Signals hidden in the radiation further deepen the concern. The energy graph didn't resemble routine particle decay. Instead, its waveform paralleled those found in early universe inflation models, echoes of Big Bang radiation. The uncomfortable implication soon arose. Did the collision trigger a localized version of cosmic creation inside our own world? When CERN's analysts processed the full data weeks later, the discovery was impossible to ignore. The radiation signatures bore no resemblance to known decays, but eerily matched the expected spectrum of the universe's oldest light, the cosmic microwave background. The distribution looked like a fingerprint from a universe's first breath. Explained cosmologist Dr. Sarah Hernandez. That's not just unusual, it's revolutionary. The microwave background is the residue of the Big Bang itself, traced and mapped with intricate detail. For human technology to reproduce characteristics identical to it suggests the collider briefly recreated conditions from the dawn of creation. In other words, splitting the singularity may have triggered a miniature Big Bang event with its own inflationary drive. Mathematically, it appears to have momentarily formed a pocket of alternate vacuum. Observed Dr. Marcus Liu, a theoretical physicist. For those instants, the laws of physics inside that space may have diverged completely from the ones we live under now. The implications ripple outward. Could our entire cosmos be the product of exactly such an event, initiated within some larger-scale reality? Is our universe itself the result of another singularity splitting open in a higher dimension? And the most alarming question: if such a pocket of space tries to keep expanding, can it consume what surrounds it? Consider the consequence. You rupture a black hole, and what spills out mirrors the opening act of the universe itself. That isn't just experiment, that's origin. Not physics alone, but code. And if that sequence can emerge, what else might follow? To fully grasp it, we must shift perspective. This wasn't about identifying a new particle or tweaking an equation. It may have been a glimpse into the forces that birth entire realities. Black holes and the Big Bang aren't opposites. They are bound by similar extremes: density, energy, and the collapse of physical law. Some theorists have long speculated that our universe could have budded off from a black hole formed in another layer of reality. CERN, unintentionally, may have pulled back the veil on that very process. The haunting part is this: the radiation signature didn't only recreate early universe conditions, it carried embedded structures, as though carrying deliberate encodings. Some are calling it vacuum code. It suggests that the apparent emptiness of space isn't void at all, but a matrix, a computational foundation. Hidden within it lies the programming that dictates how particles form, how forces bind, and how the universe evolves. What leaked through wasn't just energy. It may have been the language of reality itself. By splitting a singularity, CERN may have briefly exposed the hidden framework of reality itself, a kind of underlying operating system. Consider the implications. If the universe runs on a coded substrate, and we've touched it, then humanity is no longer confined to observing laws of physics. We might, at least in principle, become editors of them. But here's where things get unsettling. If a singularity can leak information outward, the portal may also allow inbound interaction. In the milliseconds after the split, detectors recorded anomalies, patterns that didn't align with any recognized model. A small circle of theorists now suspects these distortions could represent influences coming from outside our reality. Without realizing it, we may have pried open a door, and what was beyond may have noticed us. This leads into the so-called vacuum code hypothesis. Some physicists cautiously suggest the vacuum of space is not empty at all but encoded, a lattice of mathematical rules that set the constants which govern matter and energy. If that's true, then tearing apart a singularity doesn't merely unleash power. It could alter lines of reality's operating script. Briefly, gravity faltered. Decay rates surged unnaturally for 0.00003 seconds. Time itself wavered. Our bedrock laws ceased to remain constant. While not yet mainstream, such speculation is gaining traction. Championed by researchers like Dr. Max Tegmark of MIT with his mathematical universe hypothesis, the claim that the cosmos is, at its core, purely mathematical. Quantum fluctuations, the apparent popping of particles into and out of existence, may follow these embedded rules, not chaos. As quantum theorist Dr. Lisa Randall explains, what looks like empty space is actually a dynamic grid of information that encodes the constants of nature. The CERN split gave physicists their first measurable glimpse of this hidden layer. During those 0.3 seconds, sensors registered fluctuations where no variation should exist. The electromagnetic force weakened by 0.5%. Quantum decay rates jumped above theoretical predictions. And more disturbingly, synchronized atomic clocks fell out of sync by several microseconds, pointing toward localized distortions of spacetime itself. It was as though the event temporarily rewrote the physics engine for that entire chamber. We observed something closer to a fluctuation in the vacuum state itself, noted one CERN researcher. Speaking off the record, these inconsistencies suggest that manipulating a singularity, a point where space-time collapses, may grant access to deeper mechanisms that regulate the cosmos. It's like stumbling upon a backdoor into the program that runs reality. But with that comes danger, because rewriting code means unintended consequences. Buried inside the post-event logs was the biggest shock, yet evidence of a particle that should never exist. Call it the anomaly particle. Its properties diverge from all standard quark or lepton behavior. Heavier than predicted, oddly stable, carrying an electric charge fractionally misaligned from our models. Something entirely foreign, yet undeniably real. A signal that whatever occurred, the singularity split didn't simply reveal new energy. It may have spawned new matter. Matter born from rewritten instructions of the universe itself. What appeared in the data bore a disturbing resemblance to a long-feared possibility, a speculative particle built from strange quarks. One capable, at least in theory, of transforming ordinary matter into more of itself. Though it broke down in mere milliseconds, the implication struck like a thunderbolt. Had CERN inadvertently produced a particle that could trigger a chain reaction? Weeks later, when physicists meticulously reviewed the split singularity data, they discovered an anomaly that sent shockwaves through the scientific establishment. Hidden in the cloud of exotic debris was a quark configuration no physicist could slot into the standard model. It carried unusual properties, eerily similar to what theorists long predicted for strange matter. Nobel laureate Dr. Frank Wilczek explained that this new cluster contained a disproportionate concentration of strange quarks, far higher than seen in up or down quark assemblies. This aligned almost perfectly with theoretical models for a strangelet, a hypothetical structure of matter that had raised alarms since the early days of high-energy collision research. The worry was simple but terrifying. If a negatively charged strangelet were ever stable, it could begin converting regular atoms into strange matter. Domino style, one particle at a time. the cascading effect would spread outwards, atom by atom, with no explosion, just an inexorable, unstoppable rewriting of matter itself. These nightmare scenarios weighed heavily on safety panels before the Large Hadron Collider was even switched on. After exhaustive reviews, experts concluded that collider conditions simply could not reach the thresholds necessary to produce such objects. And yet, evidence now suggested that one may have formed for a fleeting instant inside the aftermath of the split singularity. Thankfully, the anomaly proved unstable, collapsing after only 17 milliseconds. Even more relieving was the discovery that it carried no negative charge, the very feature that could make it catastrophic. Still, its short-lived existence rattled the foundations of particle physics. If the impossible took shape, what else might? Its appearance during a singularity split isn't coincidence, said Dr. Helen Schmidt, an experimental physicist. It suggests a relationship between extreme spacetime conditions and the birth of exotic matter. That is what makes this so unnerving. Safety models had never accounted for tampering with spacetime symmetry itself. The LHC was never meant to split a singularity, and when the fundamental fabric shifted, something unexpected found room to take form. Physicists were left to confront the gray goo version of physics, a particle not intelligent, not malicious, but governed by rules that could eventually overwrite entire planets. This one died quickly, but the unnerving fact remains: its very appearance means the impossible is no longer impossible. The original safety net had been the numbers. All calculations concluded that LHC conditions made Strangelet creation virtually impossible. But a singularity split produced circumstances no equation had ever addressed. For a breath of time, the constants of physics were suspended, rewritten, and in that altered sandbox, something emerged that should never have existed. Theories began to multiply. Was this particle a remnant? A relic of a micro-black hole? A momentary ripple in the vacuum itself? Or perhaps something stranger, something tied to dimensions beyond the four we know? One theorist whispered that the singularity may serve as the edge of another reality, and, in splitting it, CERN could have momentarily peeled back that interface. Not a portal, not a gateway, but a leak. Our models don't even begin to capture what just happened, admitted Dr. Elisa Randall of Princeton's Institute for Advanced Study. We're facing phenomena outside every framework we've built. We've crossed into completely uncharted ground. The first explanation put forward was that CERN had accidentally created a black hole relic, a stable fragment that inexplicably survived after Hawking radiation should have forced its collapse. Such remnants have long been theorized but never observed. A second theory argued that the split singularity triggered a violent vacuum fluctuation, a brief distortion in the quantum fields that weave through empty space. But the third idea, far more radical, has gained momentum among theorists working at the bleeding edge of higher dimensional physics. According to Dr. Ramon Sundrum, whose research in brain cosmology has reshaped thinking on extra dimensions, the singularity might be something deeper than an infinitely dense point. What if a black hole isn't simply a singularity? Sundrum suggests, but a boundary, a place where our four-dimensional spacetime brushes against something else. This interpretation ties back to established frameworks like string theory and M-theory, which both propose that our universe may be a brain, a vast, membrane-like sheet embedded within a higher dimensional reality. If that's the case, the singularity split could have briefly torn the surface of this membrane, producing what some now describe as an interface exposure. Supporting this idea, the radiation signatures detected during the event displayed unusual non-local correlations, effects that standard quantum mechanics cannot account for. Information appeared to have been shared instantaneously across separated points in space-time, as though the fabric itself was re-threaded into novel connections. The data points toward a temporary coupling between normally isolated regions of reality, explained quantum information theorist Dr. Juan Maldacena. It's the sort of result we'd expect if two brains made contact. This isn't just abstract speculation. If our universe really is a brain suspended in a larger dimensional structure, then disturbing its edges could create consequences beyond anything we can anticipate. The split singularity may have created a short-lived leak across that boundary, allowing energy, information, perhaps even exotic matter, to seep through. And if passage is possible in one direction, the reverse cannot be ruled out. The consequences didn't appear immediately, but within hours. Anomalous readings surfaced worldwide. Precision atomic clocks in Switzerland and Japan drifted out of sync by billionths of a percent. A geosynchronous satellite over the Atlantic registered a fractional but measurable dip in gravitational strength. Nothing catastrophic occurred. No disasters unfolded, but still, a scar was left, evidence that something fundamental had brushed against our world.